Hi, everyone. My name is Shah Selbe. I am a fellow with MCAF with the New England Aquarium. I'm a National Geographic explorer, and I'm the founder of an organization called Conservify, which today I'm going to take you on a tour of, and I'm going to show you some of the projects that we're working on. And I hope to talk to a lot of you guys about any questions that you might have. We're kind of an interesting organization. We work on developing technologies. So everybody who works for Conservify are, engineers, designers, software engineers, like all those sorts of roles that when you think about conservation in the world, like you don't usually think about those as being core people who are involved in the process, but they are. And we develop tools to help scientists and conservationists better understand the planet, see how things are changing, explore places that they haven't been able to explore before, do lots of interesting stuff. So some of the examples that I'll show you will kind of demonstrate that. There's a few things that I'm going to talk to you about kind of quite a lot, and one of them is a project that we have that's called FieldKit. So if you go to fieldkit.org, you can learn more about it. But basically, the idea behind FieldKit is when it comes to a lot of the science that happens in the world, or even the data that conservationists use to better protect, marine protected areas or forest reserves or places like that, they make those decisions based off of data, based off of what they know about those ecosystems. And so what we do is we try and create better tools for them to gather that data, because right now, if they want to go and gather that sort of data, it's very expensive. The tools that are out there are very difficult to use. They tend to be very technical, so like not everybody can use them if they would like to use them. And so we decided at Conservify that we're going to start creating tools that were easy to use, that were accessible to anyone, from like the most well-known scientist in the world to a student, a fifth grader in Los Angeles, which is where we're based. Anyone who is interested in like using these sorts of tools to explore the world around them, understand what's happening around the world. We wanted to create better versions of that. So we do that a couple different ways. One is we design the tools from the ground up, starting at the very scratch. And I'll show you how we kind of design and build some of that as I walk around the lab here. But we design these things with the conservation goals in mind. So a lot of times science and conservation uses tools that were maybe designed for other things. They were designed for the military, or they were designed for academics. And so they're not suited to really be able to use by everyone, by anyone. And so we design things in that sort of way. Everything we do here is open source. So you guys might have heard some of that before, but what open source basically means is that when we design something or like invent a new technology or whatever it is, like we take everything we know about that stuff. We take the software that we write around it, the design files around the hardware, any kind of instructions or anything, and we just put it online for free for anybody to use. And we do that because, me personally, I want to make this stuff easier for the world, because I want to make sure that we can protect and conserve more of this planet. And that's only going to happen if we make tools available to anybody. So we do everything that's open source. This lab, Conservify, is a nonprofit. So, we're not trying to make a lot of money off of this stuff. We're just trying to do something better. So behind me, you'll kind of see it's a very interesting place, which is why I wanted to do a tour. Most times when you think about technology labs, you think about, a lot of engineers sitting behind their desk or like building things by hand, but it's not really connected to adventure. But, we have a bunch of stuff that I'll show you as I'm walking through, because once we actually build this technology, we take it out into the world and we go on these expeditions all over the planet to be able to do these sorts of things. So we have a kayak here on the wall. This kayak, the plan around this kayak is to put a bunch of sensors on it. And we have a different version of the kayak in the back where we're going to make that into a robotic kayak. And we're going to go on an expedition with both this one that a person can sit in right there, but also the robotic one could follow along and gather the same sort of data. And then here you'll see up on the wall right there is a drone. So I do a lot of work with drones. So I'll talk about that in a second and some of the projects that we've worked on when it came to drones. But drones are a really cool technology. They, they've gotten very popular over a couple of years. I started working on drones in a time when if you wanted to build a drone, you had two options. Or you wanted a drone, you had two options. One was you bought something from the very expensive companies out there that were making it, companies like Boeing and all these other companies. And what they were doing was they were building drones that cost millions of dollars, hundreds of thousands of dollars, right? Something that was very difficult for people to get. And then the other side of it was the early stuff that I was doing, where we would take remote controlled aircraft, so RC aircraft that a lot of people were flying around for fun, and we'd put an autopilot on it. We'd write all this code and try and figure out ways that thing can fly itself. And so this is like a later version of one of those by a company that is no longer building these sorts of drones, but this was something that we flew around for a project that we had called Soar Ocean. And Soar Ocean, the whole idea was, let's use drones to protect the ocean. How do we make sure that people aren't fishing in places that they're not supposed to be fishing? Or how can we, build drones that can help to monitor the animals that are around the ocean? And that's some of the stuff that that I've done a lot of. But basically what Conservify is doing, before I start walking around, is we're trying to harness all the amazing things that we all know has happened in technology. A lot of it is because of things like this. So, the smartphone basically came out, just over 10 years ago. And it's already fundamentally changed everything about how we live our lives. You find these sorts of smartphones in every part of the planet, and people use them for banking. They use them for communication with all their friends and family. They use it for literally everything. And when you have a technology that has become this popular, the cool thing about that is that all the little bits and bops and parts that are inside of this thing become very inexpensive because they're building billions of them. And so we take those little bits and bops and we make inexpensive tools for scientists, is basically what we're looking at doing. So I'm going to take you on a tour of the lab. The lab is in downtown Los Angeles. That's where I'm based. But the team that's working at Conservify and the team that's working on FieldKit is distributed all over. We have people in New York and in Portland, and we work with collaborators in Africa and the Amazon and all sorts of different places, just to try and make sure that this tool actually works. So I'll explain more as we kind of walk around. But let me just switch the camera around so I can do there we go. Okay, so here is part of the Conservify lab. So if you look, in this general area is where we have like a lot of our meetings. There's a little museum that I'll walk through in a second, and you can see some of the projects that we worked on the table there that I'll talk about individually. But we have different work areas where we do some electronics work, where we do things like 3D printing and laser cutting. But let's just start talking about the projects first, and then we'll talk a little bit more about this. First thing I do want to note is this is our little mascot. We call it Krabby, so it's like a crab that I found in an antique store. But some of the other projects that we're working on, some of the things that we focus on, one is around cameras. So cameras are a big tool for conservation to try and understand what animals are doing. This is usually used on the land quite a bit. It's called a camera trap. It's something that ecologists like to use, because when you put this thing up on a tree or you put this thing on the beach or something, you can actually see what animals are doing without spooking the animals about what's happening, without people being around. And so the way it does that is it has this little area that's a motion sensor, and it's got the screen for the camera and a flash. And so as we try and understand how these things work more, we take them apart, we dig deep into them. This is what the flash looks like. You can see right here that there's the camera, and this is the circuit board. So this thing is a very complicated thing, but we try a lot to understand these things better so that we can build better and cheaper versions of these things. So cameras are something that's very important to the FieldKit project, which I'll talk about shortly. This right here is one of the projects that we worked on a couple years ago, and this was a buoy. You could see there's some sensors in the bottom of it. This has a little steel dome to protect it from rocks. But this was a prototype, a buoy that we built for a project in the Amazon rainforest around understanding the water quality in this part of Peru that has this boiling river. So the river is actually so hot because the water comes up from the depths of the earth, but it makes it so hot that it's boiling. So when you have something that's boiling, it's very dangerous for people to be in it and around it. So what we did was we built this little thing that traveled up and down the river and took water samples as it did that. And then we brought that data back and we gave it to the scientists that we're working with. We've done other sorts of prototypes on buoys before. This is something we're working with another project with an organization called the Wildlife Conservation Society in the Amazon. So here's just a prototype of a buoy. I made this thing off of what's called a CNC machine that basically cut this out of foam, and then I covered it in fiberglass, and we built all the circuits and everything involved in that, and used this as a test, as a prototype. And we even build kind of low cost sensors around trying to do this. This is what's called a pressure transducer. Measures the pressure and the depth of the water is basically what it's supposed to do. This right here is a different project. So this is a collaboration we had with an organization that's called Rainforest Connection. So the idea behind Rainforest Connection was, there's lots of people who have these smartphones and then they don't use them after a year or two. And what if we took those smartphones, we put a nice microphone on it, and we put it up into the rainforest, and we had it listen for things like, illegal logging, so people trying to cut down trees and all this sort of stuff. And so we had an idea that, like, what if we took the technology Rainforest Connection was working on and we listen underwater? We try and find boats in places that they're not supposed to be. We try and find where people are fishing in areas that they're not supposed to be fishing. So instead of a microphone, we connected it to this thing right here that's called a hydrophone. And then we put like a cellular antenna that can bring the data back, and these solar panels. And, this little prototype was sitting out in the port of Los Angeles for a year and a half, gathering a bunch of data so that we can try and better understand it. And so the technology moves so fast that this thing is now completely obsolete. We would move on to doing a totally new and different sort of thing nowadays. So, over in this part of our lab, we have what we call the museum, which is basically just previous, circuits and projects and all sorts of different stuff that we've worked on in the past. Things with National Geographic, things that went to Africa, things that went all over the place. And then some of the projects we've worked on have won awards. So we've kind of put that sort of stuff there. But we have like a lot of kind of random knickknacks and stuff that we've brought back from expeditions all over this lab, which is kind of cool. It's very different. It's a unique sort of place. You have all these sorts of electronics building stuff over here, but then you also have expedition equipment and things like kayaks and all sorts of stuff over here. So I'm going to quickly talk about the FieldKit project, and then I'll tell you a little bit more about how we build these sorts of things. So this right here is actually a pretty close to being done version of what FieldKit is. This is an enclosure that we designed ourselves. It's waterproof. It's much like a thing like a Pelican case, if you've ever seen those things before. So it keeps water from going out. And then we've created these sensors inside. So this one right here has a water temperature sensor, and then a conductivity. Conductivity is a measurement that measures like how salty the water is, salinity, and some other things. So we've designed all of these circuits, and we created this thing. The cool thing about FieldKit is that each one of these are sensor modules. So if you want to measure something, if you want to add a weather station to this, if you want to measure pH or air quality or whatever it ends up being, you just plug it into one of these little slots and the thing starts working right away. So it's really kind of cool. It's kind of unique. I just turned it on so you can see the screen turning on there. But it allows you to do a lot of really cool and interesting stuff. See, there's some lights turning on. This one right here, we auto-generate the names on these. So this one's called Yellow Eagle, but you can rename it. The other parts of FieldKit that we've created is beyond just this open source hardware, is we have an app that you can play with that allows you to kind of interact with this and download data off of it. And then the last bit is we created this really beautiful website that allows you to kind of explore the data and understand. So one thing I will say about FieldKit is, this year was the 50th anniversary of Earth Day. And to celebrate that 50th anniversary of Earth Day, we're giving away 50 of these. So it's either water quality, and the water quality measures things like pH and conductivity and temperature and dissolved oxygen, or a weather station. And you could get this for free if you want to actually just go to the website and apply for it. But the one thing I'll say is that it ends on Friday, so you'd have to go pretty soon. So that's at fieldkit.org/Earth Day if you're interested in doing that. But we've designed this whole thing from the ground up. So all these electronics that you see in here, this beautiful case that you see right here that's waterproof, this handle in case you wanted to carry it around, a bunch of accessories, but already we're planning on, or we are sending these all over the world on projects in the Amazon, that are on glaciers, that are in rainforests, in plains, all sorts of different places. So it's going to be a pretty exciting thing to see how this is. And as I said earlier, we build this so it's easy for anybody to use. So if you're a student, or if you're just a person who is curious and passionate about nature and want to better explore and understand the world around you, then come and apply for a free one of these, and we'll send it to you, and you can tell us about the environment that you live in, because that's what we want to do. We want to make this easier for everybody. So some of the different areas that we're doing different stuff inside of the lab, this is where we build a lot of electronics. And actually, you know what? Here's a perfect example of the kind of difference between the stuff we have here. This is all stuff to build a circuit board. And then right here, you see a bottle of insect repellent that's sitting there. But when you build these sorts of things, it's kind of cool. So we lay out and we design these little circuit boards. On them, you put these like very small little components. So let me just show you some of these things. They're tiny. They're like the size of a grain of rice or something. I could put them on the end of my finger so you could see how really tiny small they are. It's an amazing, remarkable thing. So we take that, we put solder on it using these sorts of stencils, which I'll show you something pretty cool about that in a little bit. And then we bake it inside of these little ovens. And that puts all those resistors and the computer chips and all the different parts that need to be a part of this thing to make it work. It puts them all together. Over here, we have just some of the drones that we've worked on in the past. So we do two different types of drones. These are maybe what you've seen before as things like Phantoms. They're called quadcopters. They have these rotors that lift them up. They're really good for projects that you need to fly off of a boat or in the middle of a rainforest. So some projects we've done using these. The most recent one we worked on is actually with another MCAF fellow, Asha DeVos, who's working on understanding blue whales in Sri Lanka. So I traveled to Sri Lanka with Asha. I flew drones just like this to go up and fly above the blue whales and understand stuff about the health of the blue whales and how the whales are interacting with things like the whale watching industry over there. And then we have things like the fixed wing drones, the one that you saw up on the wall right there. And then things like this one right here. So this one here in a box is kind of a more sophisticated one. This one was sent to us by some of our friends who work on engineering at Red Bull. So they do a lot of like kind of extreme sports, and they weren't using this anymore. So now we're going to use it for some of our expeditions. This part of the lab over here, we have a lot of what we call our mechanical prototyping. So this is a big laser cutter. You can make like little brackets and things like this. This is something that we made like a little mount. And then, 3D printers. So a lot of this areas where we do a lot of that sort of 3D printing and prototyping. You can see we have 3D printer, lots of them. And then, as I said, also expedition equipment. Everything in this box is for climbing trees. In December, we were in Cameroon, which is in Central Africa, in the rainforest, putting some of our FieldKit sensors out there and climbing, 20 meters up into a tree to deploy a lot of this stuff. And then, back here, we do a lot of like drilling and mechanical stuff. And then Over here, we have an area where we do testing. So we have different equipment we can test, and then different stuff where we can build. So one of the cool things that I actually wanted to show you is how solder works on these sorts of things. So we have one of those boards down here, and I could show you a kind of a neat thing that we see over here. So if you look at the screen right there, the screen will show you the little bits of solder that are on there. And if I were to just apply a little bit of hot air to that, you could see it's going to move. Just give me 1 second. There we go. There we go. So you see all that solder that's moving, and it's actually just going to all the different little places that you see the copper on it. And that really neat action that you see there allows us to put really small things on there and make it work pretty well. So we use these microscopes so that we can better understand what's happening when we're trying to build and design these things, and make sure that we're doing it in a way that that doesn't have any technical problems. So it's kind of a neat thing to see that it just zoom right onto the little copper pads. But that's what it looks like when you solder. So when we're designing FieldKit, we go through a lot of prototypes that we 3D print. These are all different prototypes of that enclosure, that FieldKit enclosure that you saw. So, we do different designs, we try different things, we do testing on them, we test different colors, so you can see different colors there, and different surface designs, all before we finally get to something that we really want to do for the final product. And then here's some of the earlier FieldKit prototypes. We have the circuit boards that we have right here that do a lot of like the brains behind FieldKit, and different sensor modules for different sorts of things, and they all interface with different sensors. So this sensor right here is what's called an ultrasonic distance sensor. It uses a sound, ultrasonic sound, that comes out of that to tell how far away something is. This right here is a particulate matter sensor. So this measures the amount of stuff that's in the air, like particulates that are in the air of certain things. We have some of our weather station boards, some of our other things. Everything we build runs on solar power. So here are 2 different solar panels that we've worked on in the past, because we just want it to be sustainable and keep on running. And then, this little area right here is like the work area where all the employees sit. There's nobody here, obviously, because we're all in quarantine right now. So I just came into the lab just to give you guys this tour today. But, this is my desk, and then the lead engineer behind FieldKit, Jacob, he sits right there. And we also have a lot of work stuff at our desk. So you can see a weather station right there that's used for testing, a bunch of different technical equipment. We have this fish tank in the lab that has one of the FieldKits that is actually running on it right now to do testing, and we can put new software on there and see how things change and kind of understand the water quality differences. And then here in my desk, I have things like a 3D printer back there, so I can run a lot of prototypes through that and better understand it. But yeah, I mean, this is pretty much what the lab looks like. It's a really neat little place. I mean, it's a place that we allow to be open for any of other people who are working on this sort of thing. So if there's anyone out there who ever has an idea about conservation technology and wants to find a place where they can build it and understand it and prototype it, we open our doors here, and we allow anybody all over the world to kind of build their stuff here if they want to. My goal is just to make this stuff easier for everyone and create a situation where we don't have to really worry about the things that we're doing with conservation. We have all the tools that will allow us to better protect the planet, protect the wildlife that lives on the planet, help stop extinctions and pollution events and things like that. And so that's really going to happen only if we make all these things cheap and easy and accessible for anyone. So that's kind of the tour. I don't know if there's questions, but I want to thank you guys all for coming to the lab and exploring it with me.
Great, thanks for having us. So we have a few questions. Hopefully, we'll get a few more. Diane asks, how long have you been doing this?
Yeah, that's a good question. So, my background is as an engineer. So I started, I was like one of those kids that knew at a very early age that I wanted to be an engineer. I would, as a little child, I would take apart my dad's expensive audio equipment and things like that, and instead of getting in trouble for it, he would show me how to put it back together, and that put this engineering bug in me at a very early age. So I went to college for engineering, and the first job that I got out of school was in satellites. So I worked on rocket propulsion engines for satellites at Boeing. And so we worked on really big communication satellites, some NASA projects, all sorts of different stuff. And I actually did that for 11 years. But while I was working there, I started wanting to do more with the skills that I had. So I was thinking, okay, I know engineering, and I love things like the environment. I want to help with things like you know humanitarian issues around the world, but I didn't really know a way to connect both engineering and that sort of thing. So I went back to grad school while I was working, and it was during that I started to work with an organization up in Northern California called the Center for Ocean Solutions. And Center for Ocean Solutions was an organization that was started between Stanford University and the Monterey Bay Aquarium and the Packard Foundation to kind of think about big problems in the ocean, and a lot of like the policy and other issues around like how do we figure out solutions for these sorts of things. And I came in helping them around a project that they were looking at in an area called illegal fishing. So what illegal fishing is right now, we basically tell people who are out there fishing how many of the fish they're allowed to catch every year, so that we can try and be sustainable. So there's a lot of like really legit fishers that are following those rules, and there's a lot of people who aren't. And the idea was like, how can we find those people who aren't? And I was trying to find them through technology. That's what brought me to drones originally, and satellites and satellite technology and some of the other things. And when I started working with the Center for Ocean Solutions, I saw a huge need in the conservation world to try and bring in new technologies, the technologies that are based on things like this that I told you about. So I started helping them with it, and it like took off. There's a lot of people who are interested in it with it. I was working with a lot of NGOs. In 2013, I became an explorer with National Geographic Society, and then in 2016, I became a fellow at the National Geographic Society to try and help them think through these sorts of things. And during that time, conservation technology became an actual field that now people can get a job in, which is quite exciting. And so I decided at the end of basically into 2014, starting in 2015, I should start a nonprofit that works on these sorts of things. And so I started Conservify then. But I first started working with the Center for Ocean Solutions probably in 2008, to around that time frame.
Great. So Penelope asks, what are some of the most fun things to do in this job?
That's a great question. I mean, I love uh, the moment that a new technology works and you actually see it doing what you want to do. So one thing about this job is that we're very used to failing at things. Like basically, when you're an engineer, you design something, and then that first version, you find 100 different ways that it doesn't work, right? But we see that as an amazing thing. A lot of people would see that as failure, but we see it as a way to improve what we're working on 100 ways. So we go and we make all those improvements, we keep on going, but we get to a point where you turn it on and nothing fails. And at that point, that's a very exciting point. That's like you built something that's going to actually work in the world. And it's a great feeling. I also absolutely love going on expeditions. I love going on boats. I love hiking through rainforests. I love all the stuff that we get to do as a part of this job, and I think that's a very unique part of this job. And so I find that as like a very fun thing to do.
Great. A good follow up question to that is from Charlene, who asks, what was your favorite expedition and why?
Yeah, that's a really hard question. that's kind of like they're very different. The ones that we work on are very different, So we do work on a lot of ocean issues, but we also work on a lot of terrestrial conservation stuff. So over the last couple of years, we've hiked up and put sensors on glaciers in Banff National Park in Canada. We've been on boats measuring water quality across the Okavango Delta in Botswana. We've gone to the Amazon and worked on water issues in the Amazon. We have a project right now that's up at the American Prairie Reserve. I've done stuff with fisheries in places like Palau. So like literally every place that I go is amazing for each of its unique traits. I've had some. I would say like if I have to boil it down to some really amazing experiences that I've had, the stuff that I did in Palau was just incredibly unique. A couple of years ago, I was doing a drone project trying to map a rainforest in the Republic of Congo, and we were doing that as a part of trying to better understand some behaviors that gorillas were doing, Western lowland gorillas were doing. So for that project, these lowland gorillas were going to the specific type of tree. They were digging very deep to the roots of that tree, and they're eating a part of the root. And why the researchers thought that was interesting was because that's not a natural gorilla behavior. That was something that one group of gorillas had learned to do and have since started teaching it to other group of gorillas. So the scientists were trying to understand how knowledge flows through that. But as a result of like doing that mapping and trying to find those trees using drones, like I had the opportunity to be absolutely surrounded by gorillas. And that was like a moment in my life that I'll remember for the rest of it, just because it's remarkable to be that close to these animals and see the lives that they live. It's a really, really cool thing. So it's hard for me to say I don't have a favorite place. I just all of them are different. It's like asking me if I have a favorite child. I mean, I only have one child, but if I had multiple children, that's what I would say.
Well, awesome. Penelope had another question about the FieldKit, and she asked, is it just the case or is it the case and the tech?
No, it's the whole thing. So FieldKit's three things. One, it's the electronics and like the actual hardware. So that includes the case. It includes the different sensor modules that we're developing. It includes the data loggers and all these. So basically, we're creating all these circuit boards that give you functionalities. If you want to bring your data back through cellular, if you want to use satellite, whatever it ends up being. And then all these different sensor modules that let you measure different things. So radiation, weather, water quality, air quality. So we design all of these things, and write all the software that allows these to run. We also design an app, a FieldKit app that works on iOS phones and Android phones. And so the FieldKit app you could. I don't know if it's probably not going to show up here, but it allows you to kind of interface with these things. It shows you the right way to kind of deploy them. And it lets you download data off of them, do a lot of like really kind of neat things. So we have the FieldKit app. And then the last bit is fieldkit.org. So that website. On that website is a data visualization platform. So all the data that you collect from these things, you can see it visualized on maps and in charts. You can play around with it. You could take interesting things you find in it and share it with other people, or like put it in other, download all that data and play around with it, do whatever you want to do. But we wanted to create the entire experience from the sensor all the way up to, the data online, so people can kind of deal with it. The whole thing's open source. The whole thing is like available for anybody to modify or do whatever they want with it. This was something that we have been working with partners over the last couple of years, deploying it in different places, but it is now probably this summer going to be available to anybody who wants to buy it. Originally, it was supposed to be available on Earth Day, so of this year, to anybody who wants to buy it. But since we're in the middle of a pandemic, we decided to kind of wait until a time that's more appropriate. And instead of like making it available for people to buy, we decided we want to give 50 of them away to anybody who wants to use them.
Well, that sounds awesome. I think a good question to end with is one last one from Penelope, who asked, how long did it take you to develop the tech?
That's a really great question. FieldKit is a project we've been working on in some capacity, so like an way earlier version for years now. So I would say, 2014, 2015 was kind of when we started thinking about this sort of thing. The tech that you see there has been mostly developed over the last year, maybe year and a half, and that's like the newest, the actual real version of FieldKit. So between 2014 and then, we were doing different iterations of it. We were working with different partners and deploying these things and testing these things and dealing with failures and all sorts of stuff to try and figure that sort of stuff out. So it's been a process to try and get it out. These things can depending on your team, can be designed very quickly and tested really quickly, or since we're trying to create something that's useful to anybody, it takes a lot more testing and understanding to get it to that sort of point. So we're focused a lot on that right now. The last thing I do want to add before, if we don't have any more questions, is that one thing that I did with my career that I really appreciate, that I think other people should maybe think about, is I found something that I love to do and something I was good at, which is engineering, and I found a way to bring it to an area that wasn't using it in that sort of way, which is conservation. And so when I started calling myself a conservation technologist, that wasn't something that other people were really calling themselves. There was technology and conservation, but it didn't come to it in the same sort of way that we're doing it here. And I do want to stress that, like, when it comes to conservation, we need all the help that we can get to try and do better at these things. We're more habitats being destroyed, species are going extinct. There's all these bad things that are happening that need people's help to change what is actually happening out there. So one thing I do want to say is that right now we're in this opportunity where whatever it is that you're excited about, whatever it is that your skills are at, if you're really good at drawing, if you're really good at software, if you're really good at anything, there's people in the conservation community that could use your help. So like, if you're excited about this sort of stuff, if you want to work on this sort of stuff, the opportunity's out there, and we would be happy to help connect people to that sort of thing. But I do want to put it out there that don't think that just because a job doesn't exist, that's not a real job that could exist. I mean, I found that I created my own career, and I think anybody out there can do the same sort of thing. And we're always happy to help people down that path if we can.